Imagine your GPS suddenly becoming less accurate, satellite signals becoming unreliable, and spacecraft having trouble staying exactly where they're supposed to be. Nothing has to go wrong on Earth. The problem can start 150 million kilometers away, on the Sun. In August 2026, periods of increased solar and geomagnetic activity are being monitored. And that matters because modern communication depends on something surprisingly fragile: the space environment around Earth. But how can a burst of particles from the Sun interfere with satellites that are hundreds or even thousands of kilometers above us? The answer begins with the solar wind. The Sun constantly blows a stream of charged particles into space. Most of the time, Earth's magnetic field acts like an enormous shield, deflecting much of this material around the planet. But when the solar wind becomes much stronger, especially when it carries a powerful magnetic field pointed in the right direction, that shield gets violently disturbed. And this is where things get interesting. The disturbance can shake Earth's magnetosphere and heat the upper atmosphere. That creates problems for technology in several different ways. First, the ionosphere, the electrically charged part of the upper atmosphere, can become disturbed. GPS signals have to travel through this region before reaching your phone or a navigation receiver. When the ionosphere becomes irregular, the signal can be delayed or distorted, reducing positioning accuracy. So your GPS isn't necessarily broken. The space between you and the satellite has changed. But there's another problem that satellites themselves have to deal with. A powerful geomagnetic storm can heat and expand the upper atmosphere. Low-orbit satellites then encounter more atmospheric drag, almost like suddenly flying through thicker air. That makes them lose altitude faster and forces operators to make corrections. And the Sun can attack the communication system from another direction too. Solar flares can produce intense bursts of X-rays that disturb high-frequency radio signals, while energetic particles can penetrate spacecraft and interfere with or damage electronic components.
The strange part is that this all begins with something that looks incredibly far away from our daily lives. A change on the Sun can travel across space, disturb Earth's magnetic shield, and eventually interfere with technologies we use every single day. So the next time your phone tells you where you are, remember this: you're not just relying on a satellite, you're relying on the space between the satellite and Earth behaving itself. And sometimes, the Sun has other plans. Subscribe to Avion Labs for more stories where everyday technology meets the strange physics of our universe.